or good evening, depending on where you are in the world, and welcome to today's Dark Reading webinar, how supply chain attacks work and what you can do to stop them. It's sponsored by Mend and broadcast by Informa. I'm Becky Bracken with Dark Reading, and I'll be your moderator today. We have just a few announcements before we begin. This webinar is designed to be interactive. The dock of widgets at the bottom of your screen will allow you to learn about today's speakers, download resources, share this webinar via social media outlets, and participate in the Q&A session that takes place at the end of our presentation. The slides will advance automatically throughout the event. You may also download a copy of the slides via the resources widget. Toward the end of our webinar, we'll ask you to provide feedback via the survey widget, which is found at the bottom of your screen. Please take a minute to fill this out before leaving us today, as your feedback provides us with valuable information on how we can improve future events. Lastly, if you're experiencing any technical problems, you can click the help widget found at the bottom of your screen, or you can type your issue into the Q&A area and we can offer you one-on-one assistance. With that, let's get on to our presentation, how supply chain attacks work and what you can do to stop them. Discussing today's topic is Dr. Jason Clark, an independent security researcher, and Jeff Martin, who's the VP of Product Management at Mend. If you want to learn more about our speakers, you can find their bios in the speaker bio widget on your screen. And again, if you want to ask our speakers any questions at any time throughout the event, you can just put those questions in the Q&A area. With that, I would like to hand things over to Dr. Jason Clark. Jason?
Thank you so much, Becky. Good afternoon, everyone. Presenting today from Holly Springs, North Carolina. Again, Dr. Jason Clark here, and I'm really thrilled to be spending the next hour with you all. Before I begin, I want to thank Dark Reading and the sponsor Mend for the opportunity to speak on today's topic, how supply chain attacks work and what you can do to stop them. Before I begin, I just want to cover a few key terms, starting with software supply chain. It just refers to the process of producing, distributing, and maintaining software components or applications from multiple sources. This includes things like open source libraries, third-party vendors, and in-house development teams. It will include a network of what I'll refer to as stakeholders throughout the presentation. This will include areas like suppliers, consumers, developers, integrators, and users. In general, software supply chain security, as we'll delve into on the next slide and the slides to follow, will be the act of securing all of those various components that make up a given software supply chain. So, a supply chain attack is a type of cybersecurity attack that typically goes after the weakest link in a complex chain of interconnected systems. It involves compromising one or more of those trusted suppliers or vendors, the so-called stakeholders, to gain access to a targeted enterprise or the data itself. It's often quite successful, actually, from an attacker's point of view, because the attacker can exploit the trust between each of these different components to achieve their end goal. It will achieve its goal typically by compromising a vendor system, software, the hardware, and often what happens next is the attacker will do something called a pivot, what that means is they'll move laterally through the supply chain until they reach their final target. From a defender's point of view, though, supply chain attacks actually can be quite difficult to detect and defend against because attackers exploit these trusted relationships. And we'll go into a little bit more about this in the slides that follow. The impact of supply chain attacks can reverberate throughout the entire enterprise. The consequences here might include things like data theft, financial loss, even embarrassment and loss of reputation, legal, regulatory liabilities, just to name a few. So it should be pointed out there is indeed different types of supply chain attacks. The focus of this webinar will be on the first one, the software supply chain. So I'll begin with that one right now. So with software supply chain attacks, these attacks, again, target the software supply chain, which again is the network of suppliers and vendors that provide the software component and services used to build and operate applications. Adversaries can then compromise third-party software, the components, the libraries, or the service, and use it to gain access to the target enterprise's systems. Next, we have hardware supply chain attacks. Commonly with these attacks, these attacks will target the hardware supply chain, which is typically the network of suppliers and vendors that provide the physical components used in an IT infrastructure. It could include things like servers and routers and switches. Even if you look at hardware in terms of like the actual kind of computer system, you can think about it in terms of firmware and chips and that sort of thing. Attackers therefore can compromise hardware components during, say, the manufacturing process by implementing and implanting malicious code or backdoors to gain access, or backdoors to allow them to control sort of the final target system. Third on this list is the human supply chain, also known as personnel. As you may have deduced, this is looking at sort of people, right? The personnel supply chain, which is, again, network of suppliers and vendors that might provide, say, human resources and staffing services. Attackers typically in this area will use your classic phishing or social engineering and other related tactics to compromise an employee or a contractor, and then which might allow them to gain access to the target enterprise's system. Similarly, it can lead to financial loss, reputational damage, and even more legal liabilities. And lastly on this list, and there are quite a few more, I should make sure I mention that I have here, is financial. So with the financial supply chain, the attacks are going to sort of target the network of suppliers and vendors that are dealing with the movement of, say, money. This could be things like payment processing, invoicing, and overall payroll. Attackers, therefore, can compromise entire financial systems or payment processing services to steal sensitive data. Each type of supply chain, as we pointed out, actually presents unique challenges, and enterprises really should take a holistic approach to supply chain attacks and supply chain security, with the goal of trying to address and mitigate as many of these different attack vectors as they possibly can. So as I pointed out, software supply chain will be sort of the main goal here, but it's important to sort of think that a lot of these supply chain attacks in general follow, we'll call, stages, right? And this is just a notational example, right? Sometimes these stages kind of differ, but generally speaking, it'll probably follow some sort of ebb and flow that looks something like this. So, there's other ones, but this is the common kind of stage and process that I see. So I'll begin with reconnaissance. Here, adversaries will research their target and identify vulnerabilities in the supply chain. They're going to do that kind of initial research to figure out, some of the finer details. And this will involve things like gathering information on the suppliers, vendors, partners that are all part of the target's supply chain. At some point, they will go into the initial compromise. Attackers then will gain access to, say, a vulnerable point in the supply chain, such as compromising a third-party supplier or vendor. This, again, might include phishing attacks like I talked about before, other social engineering tactics, to even do things like trick employees into providing access credentials. Here in sort of stage 3, we get that pivot or lateral movement, as I talked about before. So kind of the idea is once the attacker is inside the supply chain, they will try to move laterally to gain access to, say, other systems and other data within the target enterprise. For this, they may use things like stolen credentials or otherwise exploit vulnerabilities in software and systems to basically move deeper and deeper into the target's infrastructure. Number 4 on this list is escalation of privileges. Attackers here are going to try to seek to gain administrative access to critical systems within the target enterprise. They may be looking and going after things like DCs, domain controllers, or other servers that hold sensitive data. And then here in stage 5 will be the sort of the data exfiltration stage, if you will. The final stage of a supply chain attack is typically to do something malicious, which might be like exfiltrate data or otherwise cause disruption within the target enterprise. Here, attackers may steal sensitive information such as intellectual property, customer data, financial data, or they may just try to cause system downtime and other damage. Again, it's really important to note that all supply chain attacks don't necessarily follow this exact sequence. Attackers are smart, right? They're going to use different tactics and techniques depending on their goals and the target enterprise's defenses. However, I think it's really imperative that by understanding sort of these stages, enterprises can take steps in a way to prevent and mitigate and detect supply chain attacks before they cause significant damage. So some of the webinars, I like to kind of go back in history and also kind of talk about, like, this is not just, some scary person in the closet. This is a real, obviously, thing that's happening. So the point of this slide is not to go all these in too much detail, but just kind of highlight that we have seen a number of supply chain attacks over the years. So these are just some of the more recent ones that I'm aware of. I'll just try to highlight a few, but I'll begin right sort of in the middle with SolarWinds, which is the most well-known one on this particular slide, at least. So with SolarWinds, this happened around 2020. It was a highly sophisticated and widespread cyber attack that actually affected many enterprises, even including the US government. The attackers ended up infiltrating SolarWinds, which was a software company, and then inserted malicious code into something known into its Orion software updates, which were then distributed to a number of SolarWinds customers, including, again, the government. In 2019, so a year before SolarWinds, there was a supply chain attack associated with ASUS, the ASUS supply chain attack, whereby the attackers compromised the software update mechanism for ASUS, which is a popular computer manufacturer, and then distributed malicious versions of some of their software associated with live updates. It was like a live update utility, and that hit a lot of their customers. The malware actually was designed to specifically target a number of high-profile victims. And then way back in 2017, CCleaner, some people call it CC Cleaner, by the way, attackers compromised the update mechanism for this popular optimization tool, and then ended up distributing malicious versions of the software that was actually downloaded by millions of users. The attack was attributed to a Chinese threat group, I believe it was called APT-17. So just a few examples out there. Of course, if you search supply chain attacks over the years, you'll find many, many more. But I think this just gives a sense that, at least from 2017 to 2022, we've seen quite a few, and there's so many of them that are kind of missing on the slide as well. But I think SolarWinds is maybe the best well-known example if you do need to provide an example to, say, your leadership, or maybe in some sort of lunch and learn type of session that you might be doing at your in your company. In general, though, I'll just kind of close this by saying I think the attacks here, again, kind of demonstrate that potential damage that can be caused by exploiting weaknesses in the supply chain. I think it also does a good job, especially if you get into the finer details, that will show and highlight the importance of strong security measures, supply chain risk management practices to prevent against such attacks. So this slide is meant to kind of show that there are several what we'll refer to as common vulnerabilities that can be seen in the supply chain. And so once again, in the time that we have here, this slide just kind of scratches the surface. But I'll start with just a general vulnerability associated with a lack of code review and lack of code testing. I think insufficient testing can actually result in a number of vulnerabilities going undetected. I think enterprises should have a comprehensive code review and testing process in place to identify and mitigate any potential security issues. The other thing that we see quite a lot is just outdated software. So this old, unpatched software can leave systems vulnerable to known security vulnerabilities that can actually be exploited by attackers. Third on this list is poorly designed access controls. In general, poor designed access controls and unauthorized access in general, this weak authentication mechanisms and insufficient access controls can allow unauthorized parties to access sensitive data and systems within the supply chain. And then I have here lack of encryption, meaning also insecure communication. So with weak encryption here, just the fact that encryption in general is an essential tool for protecting sensitive data But if you're either not using encryption or you're using some sort of weak encryption algorithms or not implementing it quite right, this can actually lead to a number of supply chain attacks, even associated with data breaches, for example. So this is a common vulnerabilities. I won't spend too much time here because a lot of this is sort of, I think, kind of well known and well documented. But this next slide is a little bit more interesting, if you will. So here it's thinking about hidden vulnerabilities. And so I think insufficient monitoring and detection kind of comes to my mind, and this can occur for a variety of reasons. For example, an enterprise might not have the necessary tools or expertise to even effectively monitor and detect threats in its supply chain. This can do things like lead to delays in identifying and responding to attacks, which then can increase the severity impact of those attacks. Another factor that can contribute to this insufficient monitoring and detection is just a lack of visibility into the supply chain. This typically occurs when an enterprise does not have access to information about its suppliers, its partners, and other third-party vendors. So without this information, it can be very difficult at times to identify potential vulnerabilities and threats within the supply chain. Next, we have third-party dependencies, and often see this a lot as well, whereby software applications often rely on third-party libraries and components, which can therefore introduce vulnerabilities if they are not properly managed and updated. These hidden vulnerabilities in these types of dependencies can really be difficult to detect, especially if the enterprise does not have visibility into something like the source code. The lack of diversity in software suppliers can also contribute to these hidden vulnerabilities. What I'm driving at here is if an enterprise, for example, relies on a single supplier for its software needs, it may not have that visibility into the supplier's security practices or vulnerabilities. It can also, make it difficult to detect hidden vulnerabilities in the software supply chain. I also think that in some ways, a lack of diversity in software suppliers might actually lead to something like a lack of competition in the market, which could end up, having lower quality software and fewer incentives for suppliers to invest in security. I don't see that quite as often, but it is just an interesting point to make. And then lastly, on this list, I have attacks targeting open source software, and open source software is really crucial in this area as well. Attacks targeting open source software supply chain, can be particularly concerning because of the potential for hidden vulnerabilities to be introduced in the supply chain. Open source software is widely used and is often relied upon by enterprises for things like critical applications, which makes them an attractive target for attackers looking to exploit vulnerabilities in the supply chain. There's several ways in which attackers can target open source software supply chain to introduce these hidden vulnerabilities. Okay, so the next thing I want to talk about is how do you go about as an enterprise assessing your current supply chain security? I think it's imperative, first and foremost, that enterprises actually do this, right? That they go about assessing their current supply chain, as it's an important step in identifying and addressing these potential vulnerabilities. Here are some tactics, if you will, for kind of conducting a supply chain security assessment. And I'll begin by just talking about the need to identify software suppliers and partners. In many ways, this is often the first step in assessing your supply chain security, is to go about identifying those suppliers and partners. This might include creating an inventory of all the companies you work with, including their vendors, their contractors, and their other related partners. Next, it's highly recommended that you go about conducting a risk assessment and coming up with remediation plans. I think it's really important to conduct a risk assessment to identify some of those common vulnerabilities and hidden vulnerabilities and potential vulnerabilities that I talked about before. This might involve doing things like evaluating each company's security policies and controls, as well as assessing their overall compliance with regulatory requirements. Third is just an overview and a review of your current controls and policies. the enterprise should strive to review security policies and controls of each supplier and partner to ensure that they meet enterprise security requirements. This might include doing things like reviewing policies for access control, like we talked about, or data protection and incident response. And then last on this list is kind of evaluate and redesign supply chain design and architecture. It's really important that enterprises evaluate their architecture of supply chain to, again, try to identify those potential vulnerabilities and ideally map out the flow of data between enterprises, suppliers, partners to identify potential areas and gaps where there is a point of weakness. I would say that following these kind of tactics and techniques, enterprises really can improve upon their overall supply chain security. I think by doing some of these things here, if not all of them, ideally, can help implement effective security controls to, again, mitigate the cyber attacks and other security incidents associated with supply chain. So I wanted to kind of do a deep dive on one of them, sort of risk management in general. So there's just some general risk management strategies. So starting from the top left, conduct regular security assessments. I think conducting risk assessments is really vital in mitigating supply chain attacks because it helps organizations to better identify and evaluate potential vulnerabilities and threats that could then do things like impact security integrity of their supply chain. Some of the reasons why I would say assessments are important is because, again, they can identify the potential threats, then you can assess the impact of those threats, and in general, improve the overall cyber chain resilience. I think risk assessments do play a crucial role in mitigating supply chain attacks by enabling organizations to proactively identify, evaluate, and address potential vulnerabilities and threats to their supply chain. Next, so still on the left side, one down, establish secure coding practices. This is really important in preventing software supply chain attacks by promoting good, solid, strong, secure coding practices, mitigating those third-party risks, and doing solid and sound software testing, and overall enhancing the security awareness. Next, I was going to talk a little bit about implementing the access controls. Again, this is really important as it's useful in mitigating supply chain attacks by, again, preventing those unauthorized access, ensuring confidentiality, limiting attack surface, and mitigating third-party risks, all again, while enhancing security awareness in general. In terms of establishing incident response plan, what I'm thinking about here is the importance of building incident response plans to, again, mitigate supply chain attacks, because it will actually help make things more efficient, because it'll allow your organization to detect and respond to incidents a little bit more quickly and effectively, while hopefully minimizing damage caused by the attack in the first place. I think enterprises should, again, establish incident response plan. And also what I should have on here is practice your incident response plan. I think that's a really important step. Covered encryption and secure communication not too long ago, but just for completeness here, encryption and secure communication, again, can really help with that CIA triad, the confidentiality, integrity, and I guess I changed it a little bit, authenticity. It's usually availability. But anyway, confidentiality, integrity, and authenticity can actually be really important here. And that's why implementing encryption and secure communication is really valuable. And then increase supply chain visibility. In general, I'll just say that increasing visibility into the software development and distribution process can help enterprises identify potential vulnerabilities and threats, detect malicious activity, manage third-party risks, and ensure that compliance and regulatory requirements, all of those things, which can help with the overall software supply chain attack. So I know there's a lot that I covered on this slide, but I think it's important maybe just to look at this and sort of think about what are you doing from a risk management strategy? And these are just some ideas to take forward with you if you'd like. So as an independent security researcher, I do have to stay, vendor neutral. So this slide is just meant to kind of show some of the different technical tools that you might find valuable when dealing with this problem. There are many tools available out there to help prevent supply chain attacks. And again, this slide just captures a few of them. So we have vulnerability scanners. In general, these tools can scan for vulnerabilities in your systems and software, identify potential weaknesses, and those that can be exploited in a supply chain attack. With endpoint protection software, you might try to use this software to help protect your endpoints. This could be things like your laptops and desktops and mobile devices from malware and other threats. Network security tools might play a role here to help you overall secure your network. Could be things like firewalls and intrusion detection systems, IPSs, intrusion prevention systems, and so on and so forth. Identity and access management is crucial. IAM tools can help manage your user access to your systems and data, ensuring, again, that only authorized users can access sensitive information. And then this is a catch-all, just software supply chain tools in general. These tools will typically focus specifically on securing your software supply chain. This would include like protecting third-party libraries and dependencies. So it's important to note, once again, that these tools in and of by itself would be useful, but it's not going to solve the problem. So the idea here is you want to use some of these tools in conjunction with one another, but also with your overall security measures, such as simply like employee training, the risk assessments like we talked about before, any incident response planning. A holistic approach to security is like one of my main recommendations, and I think it's necessary to effectively prevent and respond to supply chain attacks. Okay, so I wanted to introduce something called SBOMs. I don't know if any of you were on the Dark Reading webinar yesterday, as this was the focal point of the talk. But for those that are kind of new to this, SBOMs, it stands for Software Bill of Materials. And I wanted to kind of introduce this concept of Software Bill of Materials. I'll call it SBOMs from now on. And I think, again, for those that don't know, SBOMs is just like this comprehensive inventory of all of the software components, the libraries and the dependencies used to create a particular software product. In a way, it's like an inventory. Is an example yesterday with baking chocolate chip cookies. So it's like an ingredients list, if that's a better analogy for you. In many ways, it's just a detailed breakdown of the different software components and versions that are used in a particular software application. It may include metadata, which might include things like the origin or licensing terms and other important attributes. So the relationship between SBOMs and our topic of software supply chain and attacks is that the SBOM is yet another essential tool for managing the software supply chain. It can help enterprises track and manage the software components that go into their products. So by maintaining an accurate and updated SBOM, enterprises can again get a handle on that importance of better visibility into their software supply chain and ensure that they're meeting those regulatory requirements, industry standards, and overall best practices for things like software development and distribution. This in turn can then help them improve the quality and security of their software products, reduce the risks of cyber attacks and data breaches, and enhance everything from the client and user trust to basically get more confidence in their brand and reputation. So pulling the onion back a little bit, I wanted to talk a little bit about how SBOMs can specifically help. So as we discussed, SBOMs are really important for software developers, but they also have a role with anyone sort of, IT professionals, if you will, the end users, because they can do things like help with transparency, accountability, identification, and directly with the software supply chain. So I think transparency is really important, right? SBOMs make transparency possible because, again, it allows customers and users to make more informed decisions. SBOMs can also hold developers and manufacturers accountable for improving their software. With regards to identification, it can also help them identify security vulnerabilities, perhaps there's issues with licenses and other compliance violations. It's really an essential tool, if you will, in managing the intricacies of the supply chain. So what you find in an SBOM, right? So as we discussed, it's really important. And here's just a quick sample of what might be included in SBOM. There's definitely more and more information. I did a little bit more of a deep dive yesterday, but for example, you'll definitely see the name of the application and hopefully the name of the developer or author. You might include things like your version number or a release date, licensing information, code packages, libraries, and other package dependencies. You might even include, underlying systems and perhaps the programming language the application was mostly coded in, for example. You can also get into way more detail. You can do metadata, data about data. And so I think, again, it's really important to create this SBOM with a lot of relevant, useful information and make sure that you keep it updated, right? If the application goes for a major overhaul or there's a major update, make sure that the SBOM is updated. I've seen organizations do this in very simple Excel. It's not necessarily the best approach, but I would say it's better than nothing. But there's more automated ways. There's formats such as, beyond the scope of this talk here, but there's Cyclone, SPDX, SWID formats, just to name a few. And those are just good ways to hopefully keep your application updated. In terms of best practices, there is a few best practices. Actually, there's quite a few best practices associated with the software supply chain. And so just kind of included a few here. First, in box one is develop a comprehensive supply chain risk management process. I think I explored that enough on the previous slides. Again, the whole idea here is to think about identifying the potential risks, assessing the impact of those risks, and then sort of establishing security requirements and expectations around those risks, and monitor supplier performance. All those things can be baked into the risk assessment strategies that I talked about before. Also, it's really important here in box two that I have to develop and practice your incident response plan. A lot of this I know is kind of what I talked about before, but really I wanted to kind of condense it into one slide. So once again, it's really important that enterprises develop and test an incident response plan that outlines procedures for responding to supply chain attacks and other security incidents. It should be practiced, as this is quite often overlooked. With this, you also want to manage your incidents, right? Develop and implement an incident response plan that outlines procedures for the best way to respond to a supply chain attack should it happen, right? It might include things like roles and responsibilities, communication protocols, and a step-by-step process for addressing these types of supply chain security incidents. You want to also make sure that you review and improve your processes. Regularly review and improve supply chain risk management is paramount, because updating your security requirements, revising supplier contracts, and implementing new security controls will really help you in the long run. Educate and train employees and associated stakeholders. This kind of goes without say, but you want to make sure that you are always continuously, educating folks on best practices. This might include, telling developers, the updated best practices for secure coding, secure software distribution, going back to incident response planning. You want to have these regular training and awareness programs. And you also want to try to conduct these in such a way that, users are not simply clicking next on some sort of automated training site. You want to make them interactive. And there's a lot of different ways to go about doing that. So the goal here is to educate and train employees and stakeholders, and make it interesting and relevant and timely. And one of the best practices that I have is, okay, so you have all of these great ideas to protect against software supply chain attacks, but how do you do it without actually disrupting business? And this can be really hard to kind of, dance around. I think software supply chain attacks, again, they're challenging to prevent because of the reasons we talked about before. But I want to try to talk a little bit about some strategies you might think about to do so without disrupting business. So, for example, you might want to implement supply chain security, again, code signing, digital certificates, and secure software distribution to, again, minimize risks of, say, software tampering and unauthorized access. These can go a long way in helping with the integrity of the software supply chain without disrupting business. What I like to also recommend is using things like threat intelligence feeds to monitor the overall threat landscape. Allows enterprises to stay up to date on emerging threats and vulnerabilities. Also, things like implementing network segmentation or MFA, multi-factor authentication, might help. So as I get near the end, sort of running out of time a little bit, but I wanted to kind of talk a little bit about some future trends in software supply chain attack, and we can also carry this over to the discussion as well. But some of the things that we're seeing is just, again, a target of open source software. I think because open source software is becoming kind of widely used in software supply chains, attacks are increasingly targeting vulnerabilities in open source. I think we're going to sort of see even more of this targeting of open source software. Like many other attacks that I've presented on and that I've researched, I think we're becoming more and more sophisticated from attackers' point of view. And I don't think supply chains is an exception to that. So supply chain attacks, again, they're becoming more sophisticated in tactics and techniques. They're making it harder to detect and mitigate from a defender's point of view. And in some ways, they're beginning to see some collaborations between multiple supply chain adversaries kind of working together in concert for some of these sophisticated attacks. I also think there's an idea about kind of this emerging new technology. In a way, automation and AI or machine learning, I think we'll see more and more of that used frequently by attackers and actually by defenders. So this is an interesting one. It may be used to better detect, respond, monitor, and manage software supply chain attacks in real time. And generally speaking, I think there's going to be a trend for even more regulation. This might include government and industry groups, companies to develop even more regulations. And hopefully this will lead to more awareness, increased accountability, and widespread standards. So as I kind of want to conclude here, just some kind of closing remarks on software supply chain attacks. We covered a lot. They are a growing threat to enterprises of all shapes and sizes. As we saw from that diagram that gave some examples, there was no point where it kind of stopped, right? So I think it's going to be a growing threat to enterprises, especially with attacks against open source, attacks that are a lot more sophisticated. Therefore, I think it's really imperative that enterprises take the appropriate defense measures. One of the big things that I hope you took away was developing a comprehensive kind of risk management process. You want to ensure that you're building a secure software development process that starts from the ground up, the coding and the distribution, all of that. I think by implementing supply chain visibility, establishing access control and authentication, keeping your encryption in place and updated will help a lot. And then, I introduced the idea of software bill of materials, SBOMs, and I think that's another great way to, another tool in the defender's toolkit, if you will. My last kind of comment I'll just say is that comprehensive, proactive, a holistic, multifaceted approach works best when you're dealing with supply chain attacks. So with that, I've run out of time. Thank you so much for listening to me and taking the time out of your busy schedule. I will now turn it over to Mr. Jeff Martin, VP of Product Management at Mend, for his remarks. Thank you.
Thanks, Jason. That was great. Hi. As Jason just introduced me, I am a VP of Product, and so I'm going to take a little bit more product-centric viewpoint on this. Look, and I'm going to go quick because I want to make sure we leave time for questions. There's some good ones, and keep them coming. But let me go straight in. Look, supply chains aren't new. They're not unique. I'm going to focus on the software side of things, but supply chains exist all around us and for all sorts of reasons, right? Cars, I threw a picture of my car there, medical devices, even food. They all have supply chains. They all have supply chain risks. The reason I threw these three up here is you need to secure these supply chains very differently depending on the product you have. Lettuce has remarkably few lines of code, and securing that supply chain is very different than securing a car with a couple million lines of code nowadays, or a medical device where you're putting people's lives directly in people's hands. Here's sort of the very practical guide, I guess, to any supply chain, but specifically for software. You need to know what you have in there. You need to know where it's from. You need to know, is it safe? You need to make sure you have a plan for when or if it becomes unsafe. And you need to know where it's being used. It needs to be traceable. So I'm going to cover each of these a little bit. But fortunately, Jason did a really good job of covering the first two. What is it and where is it from? This is your bill of materials, your inventory. All of the things Dr. Clark just said, you need to have a machine-readable, easily communicated inventory of all of the items inside of your product. We focus on software at Mend. I'm going to keep it limited to software. But again, this is something that works just the same for hardware or firmware. And I really can't stress this enough. All security really starts with knowing what you have. But there are other questions sort of require a little bit more than just an SBOM. And Jason hit a lot of them from risk management perspective. But I'm going to come at it from a little bit more a different angle. What do we mean when we say, is it safe? I like Jason used an analogy of recipes in a cookie. How do I know the ingredients are what they say they are, and that nobody's poisoned them if I'm going to go make some cookies? So you need a few things. You need to know your supplier, and you need to trust them. You need to have desired and transparent behavior. It needs to do what it says it will do, and you need to be able to see what it does. And most importantly, this is my most practical suggestion, and I'm going to keep harping on it. You need to stay up to date. To hammer home that cookie analogy, very old flour from 10 years ago is not safe, and I don't care if it was before. There's updates. You need to refresh your ingredients. And where do these start showing up? What kind of attacks start leveraging these things? Why do I need a known and trusted supplier with transparent behavior? It's because one of the bigger attack vectors that's really been ramping up lately is malicious packages. These are pretty specific to open source, which is around 80 to 90% of the average code base right now. So 80 to 90% of the stuff that you're putting in your bill of materials is open source that you're pulling from somewhere. If you don't know who the supplier is, you are vulnerable to a bunch of attacks that are currently happening. Typo squatting, dependency confusion, dependency hijacking. These are attacks that leverage a supplier that you think you know, or that you trust already in the case of hijacking. Additionally, one thing that sometimes people forget about is brand new things. Brand new does not equal safe. It is not known or trusted. Trusted requires time. And so we're seeing a lot of these attacks come in leveraging this. Next category here, undesired and unclear behavior. This has actually been a huge spike in the last 6 months. Especially spam packages have just been spreading like crazy, and absolutely, it's like wildfire out there. Why? Because it's not getting flagged as, by the way, most of these are new libraries as well, but it's not getting flagged as bad behavior because it's not. It's doing things that are counterproductive or things that you don't desire, or maybe they're placeholders. In the case of something like obfuscated code, very often there's no actual malicious behavior there. It's a placeholder for later. So people begin to develop that trust. So you have to bring in the things that you know. And somebody give you some mic input. Thank you. I appreciate that. Thank you, Dario. But then, look, there's the good old-fashioned type, malware. We all know what this is. There's plenty of droppers out there, info stealers, exfiltration attacks. There's actual bad behavior. But that's actually a relatively small piece. A large chunk of it is things that are waiting to behave badly later. All right, let me talk a little bit about staying up to date. So here's where I talk about known vulnerabilities. Almost all vulnerabilities that are leveraged in supply chain attacks are chained together known vulnerabilities. They put together 3 or 4 or 5, do things like escalate the privileges, that nice flow that Jason laid out. A lot of the attacks leverage just things that we already know are wrong, things that are already vulnerable. Because if you don't stay up to date, this is just a list of vulnerabilities in your product. That first stage that Jason highlighted, reconnaissance. The first thing people are going to look at is what's in this product, what's in this software. Oh, great. There's a bunch of vulnerabilities that have been announced. They're public, but they haven't been fixed. Now, these are known, right? These aren't unknown. But it's shocking to me how many people try to focus on the unknown when they have huge attack surfaces of known vulnerabilities. All of the behaviors that Jason laid out, things like limiting access control, a good risk management process, those are all very important to mitigate some of these. You need them. Good access control and design will limit the applicability of a known vulnerability. But it's a lot better to just make sure you have very few known vulnerabilities and mitigate them. And this is where most people fall down in the real world, to be honest. They let code go out of date. Out of date equals vulnerable, period. Especially with open source. Now, my general recommendation here, and this is much easier for new products and new projects than for things that have been around for 5 to 10 years, is to automate dependency updates. That's the number one suggestion I usually make to people. There's many tools, they're free, that will tell you your dependencies are out of date, you should update them, here is the most recent version, and the good tools will even create a pull request for you that you can merge it in. And the very best tools will give you an idea of your functional risk for applying that. This is just by far my best recommendation is keep your stuff up to date. Keep your cupboard stocked with up-to-date ingredients. I'm going to hammer the cookie analogy. Importantly, this is not just for your code. This also applies to infrastructure and containers, right? We all have computers. These computers are all automatically updated because the central control for all of our companies applies them. I don't have to intervene. That's the idea. Your infrastructure, your containers, and your application code should be auto-updating. Like I said, this is a lot easier on a new product because it's a lot easier to start from a current base and keep doing incremental updates than to try to update something 5 years old. You aren't going to go update Windows XP to Windows 11. Okay, so now I'm going to speed up a little bit. There's the other two big questions. How do I know when or if it becomes unsafe? By the way, it's always when. And where is it being used? So here's the deal. Even if you automate everything that you can, there are things that you can't. Python jumps a version, you're not going to just be able to update the whole Python engine overnight. You're going to have gaps. You're going to have delays. No matter how much you try to automate, things fall through the funnel. And this is really just a problem of monitoring and, let's call it, prioritization. This requires one of the SCA tools. I'm keeping an eye on the questions. Randy, you asked, what are the free stuff? My recommendation is our open source project called Renovate. Feel free to use it. It's free. It's open source in and of itself. Anyways, the whole idea here is that you need to be able to monitor, scan, basically continually monitor your inventory, and when something goes out of date or has a vulnerability that is newly released, it gets flagged, and you want to be able to apply some prioritization to that, right? Not all vulnerabilities are created equal. They don't all need your attention. Some of them are frankly informational. But it's not just the vulnerabilities here, it's also malicious packages. All those attacks I laid out a little bit earlier, right? Typo squatting attacks and things like that. You need automated tools to scan this on commit and tell you, okay, great, your inventory is, I don't know, you meant to use, I don't know, something called XML and you used XLM, and now you have a malicious package in there. And then this is very, very important. Where is it being used? Jason, I think, alluded to somebody tracking it all in a spreadsheet. Good luck with that. You need a centralized place. Why? Mainly for the 0 days. Here's the deal. Most people who build SBOMs right now are building it for actually what I would call components and not their entire product. They're building it for this repo, but not the containers, right? They're not including all of the application code. Or they're like, oh, that's another team's problem. You need a central inventory, a centralized SBOM, if you will, for all of the areas of a product. And if you're a big enough company, if you have multiple products, you need one that spans all the products. And it needs to be searchable. Because when log4j pops up, you want to be able to search, where is log4j in my portfolio, and get an answer pretty much immediately. Okay. And then I'll just mention the alternative here, and then we'll go to questions. Because if you're not doing these things, what you end up with is an expanding threat surface. You're vulnerable to new methods as well. Plenty of noise. Developers hate tools that give them noise. So this is one of the main reasons I suggest automatically updating as much as possible. And then you have these very complex prioritization workflows, which is a surefire way to actually fail. You're going to miss things. So what ends up happening is your fixes and updates end up not happening. Okay, so I went through that very quickly. I left 5 minutes for questions. Let's actually tackle a couple.
Great. Well, thank you so much, Jeff and Jason. We do have a lot of great questions. But before we get to the Q&A, I just want to direct everybody once again to the webinar survey. It's available at the bottom of the presentation window. Thank you in advance for filling that out. Okay, so let's get to our questions. Let's start with Jason. Raj asks, let's go back to the SolarWinds discussion. And he wants to know which one of these common vulnerabilities led to SolarWinds. So maybe you can sort of apply what we've been discussing to that example, Jason.
Yeah, absolutely. That's a really great question by Raj. Of course, in 2 minutes or less, it's going to be kind of hard to talk about SolarWinds in any great detail. But again, back in 2020, we had the SolarWinds cyber attack. And I would say the primary vulnerability was associated with the vulnerability in the Orion platform, the software update process. So then what happened was, once the attackers were able to inject the code into the update went out to all of the SolarWinds customers who had installed that compromised software. And then from there, the attackers were able to, again, do that pivot, move laterally that I talked about, and basically gain unauthorized access, which is what Raj's second part of his comment was. they can then move laterally and then go about their way, stealing sensitive information and carry out. So in summary, it was about the malicious code on the update package. Once that hit all the customers, then they could basically pivot and use access, weak access control, and basically steal all the sensitive information. So
I think it's funny because it ties into another question I think Brian asked, right? Which is, how does standardizing vendors reduce or affect the threat landscape? It's weird because, as I pointed out, you need to know and trust your suppliers. It's very important, and the fewer suppliers you have, the easier it is to know them and trust them. However, from an attacker's standpoint, if everybody is trusting a single source, SolarWinds, that becomes an incredibly attractive target because you trust them, and if I can get in there, I can affect large amounts of people. So it's a kind of double-edged sword depending on how you're looking at it. I would generally say less vendors is better, but you always have to watch them. And if you don't know where you're using them, that's a huge issue.
Let's go ahead and just pivot to the NIST supply chain guidance and how adoption is going and what you guys are seeing in the real world that's working and maybe what isn't. Jason, do you want to just start us with that, and we'll wrap up with Jeff's thoughts?
Sure, absolutely. So definitely NIST, I think, was the recommendation by Nick. That is definitely one that we're seeing. NIST in general, the cybersecurity framework, specifically supply chain practices. The other one that I see a lot being used in terms of authoritative sources is ISO. I think it's ISO 28000, I think, which basically is a standard that deals with supply chain. It's a framework for supply chain. I've also seen things coming out of, U.S. Department of Defense, Cybersecurity Maturity Model, Internet Security, Center for Internet Security, CIS. So there's quite a few out there, but I think NIST and ISO would be a good starting point.
And I guess I'll wrap on this point. I love the NIST guidelines. I think they're great. I also think they're applicable to relatively few established software companies, especially. It's very important to kind of know the scope and scale of what you're trying to handle. Those are very good full frameworks. I used to be in medical devices in my distant past. They remind me of FDA guidance. But here's the deal. If you're not building something for the DoD and you're building a, app for, your phone that plays a game, you have very different concerns, and that is overkill. And so it's very important to not just take guidance out of the box, but apply it to the actual product and the risk profile of the product you have, as well as your company's resources. Very few people have the resources to go and fully implement like the DoD SIMs or the NIST framework. Only the biggest and most regulated companies. But I do think Jason hit the nail on the head. More regulation is coming on this, not less.
Unfortunately, we are going to have to leave it there. For all of our audience members who submitted questions, those will be provided to our speakers and they can respond to you offline. Again, thank you for all of your smart and good questions. We'll get those answered. But we want to thank Jason and Jeff. Dark Reading appreciates your time and your expertise. This is certainly an interesting topic. We want to thank our sponsor, Mend, as well, and everyone again in the audience for participating. Then the next 24 hours, you're going to receive a personalized follow-up email with details and a link to today's presentation on demand. You can feel free to invite your colleagues who are unable to join us live, and they can participate as well and take in the event. Finally, this webinar is copyright 2023 by Informa. The presentation materials are owned by or copyrighted by Dark Reading and Mend, and the individual speakers are solely responsible for their content and their opinions. On behalf of our guest Mend, I'm Becky Bracken. Thank you all for joining us, and we'll see you at a future event.